This is the problem number 33 of the section 11.5, page number 794. There are two lines L1 and L2. They are asking determine whether the lines intersect. Right. If two lines intersect, what is the property we can use? Suppose two lines like this, they intersect. You see this is L1, this is L2. You see there is a common point for both, right? Yes. If two lines intersect, there must be a common point. But if these two lines are parallel, then we cannot find the common point. It means they don't intersect. First, we check whether two lines are parallel. If we get these two lines are parallel, then we know we can't find an intersect point because they are not going to meet together. Right. So how do we check these two lines are parallel? First, let me explain these two lines. We have L1. So we have this is the XYZ. So what are the information we can get? Yes, we know the point on this line is, we know the point, these are the point coordinates of XYZ, right? Point on the line. Therefore 2, 3, 1. And also we know direction vector. Direction vector V1. How do we find the direction vector? Coefficient of t. Coefficient of t is 4 here, and here 0, and here negative 1. Right? So V1 is 4, 0, negative 1. Then let me consider L2. I use the color. So this is L2. Similarly, we know a point on the line, that is 2, 3, 1, and it's a point. And also we know the direction vector of this line V2, that is 2, 2, 1. Right. Now you see, if these two lines are parallel, it means L1 parallel L2, then V1 must be parallel to V2. Then how do we check whether these two vectors are parallel? If these two vectors are parallel, we can say L1 and L2 are parallel. Then we don't have to continue this because we know these two lines don't meet together. There is no intersect point, right? Right. So then let me check this one. V1 for 0, negative 1, and T 2, 2, 1. What is the meaning of this? If these two vectors are parallel, we can find T that is a scalar such that V1 vector equal T V2 vector. Right. So if we can find T, then we can say V1 and V2 are parallel, right? Right. Now how do we find it? Yes, 4 equal to T. From this we can say T equal to. And next 0 equal to T. From this we have T equal 0. You see these two are not equal. Therefore we cannot find T such that V1 equal T V2. We cannot find T that satisfies this condition. Therefore we can say V1 vector is not parallel to V2 vector. If these direction vectors are not parallel, then it is clear L1 and L2 lines are also not parallel. Even these two are not parallel, maybe they don't meet together, right? It means no intersect point. How do we check that? Okay, how do we check whether the lines intersect? Yes, let me consider this. So with this, maybe like this, so then they must have a common point. If they have a common point, then we can say these two lines intersect, right? Okay, now you see here we have x and here x. So at this intersect point, these x must be the same. So what I do, I set them equal together. So this equal 2s plus 2. From this we can have 2t equal s. Right. So I said this is first one. Then I set y equal together, right? Y. So then from y3 equal to s plus 3, this is from here you can say s equal 0. Right. Now we know s equal 0, therefore we can say t equal 0. Right. We used first x and y to find the s and t. Okay, now we check the third one. What is the third one? We see t plus negative t plus 1 equal s plus 1. So now we plug s equals 0 and t equals 0. Yes, you see, once we plug these values, this equation is satisfied. This is 0, 1 equals 1. Yes, it is right. You see that equation 3, this is equation 3. I say that is equation 3. Equation 3 is satisfied, and therefore we can say L1 and L2 intersect. Now substituting 0 for s or for t, we can obtain the point. So let me explain this. Right. So L1 and L2 intersect. So yes, now let me plug the values s t equals 0. Then actually for the L1, you see for the L1 x equal 2, y equal 3, z equal 1. And for the s equals 0, L2, x equal 2, y equal 3, z equal 1. So you see we get the same values of both x, y, z. Therefore we can say intersect point this is 2, 3, 1. Right. Now next question is, how do we find the angle? It means what is the angle between lines? Right. Again, these are the two lines L1 and L2. Then how do we find the angle between these two lines? So let me explain this. You know L1 has a direction vector, I said that is V1, and L2 has a direction vector, I said that is V2. So you see these two angles, this angle and vector and this angle must be the same because V1 is parallel to L1, V2 is parallel to L2. Therefore, how do we find the angle between V1 and V2? You know it is cosine theta equal V1 dot V2 magnitude divided by V1 magnitude and V2 magnitude, right? Yeah. So actually here absolute value V1 dot V2. Then we need to find V1 dot V2. So we know v1 vector dot v2 equal v1 is 4 0 negative 1 and v2 is 2 2 1. Therefore dot product is 7, right? So how do we find the magnitude of v1? You know how to do it. 4 to power 2 plus negative 1 to power 2, which is 17 square root. Similarly, we can find the v2 vector magnitude, that is, it is 9 square root, which is 3. Then we just plug the values. So cosine theta equal 7 over root 17 times 3. So we can find the theta. Then theta equal arc cos or cosine inverse 7 root 17 divided by 51. So that is the angle between V1 and V2. Therefore, that is the angle between L1 and L2 lines. That is the end of that problem. This is the problem number 34 of the section 11.5. Page number is 794. There are two lines, L1 and L2. They are asking whether these two lines intersect. If so, find the common point. Right. First, as I explained before, first we check whether L1 and L2 are parallel. Before we check L1 and L2 are parallel, let me find the information we have. So we have L1 and we have a point on the line. It is 1, 1, 4. Then we have a vector V1. So that is negative 3, 4, 2. That is the direction vector of this line. And we have L2 line. See, this is L2. And then we can find a point. What is the point? 1, 4, 1. And also we have direction vector of this line. I say V2. V2 is 3, 2, negative 1. Then how do we check whether these two lines are parallel? We have two direction vectors. If these two lines are parallel, direction vectors must be parallel. If so, we can find a scalar t such that v1 equal t v2 vector. Right, v1 vector is negative 3, 4, 2 and v2 vector is 3, 2, negative 1. Now we can set up, make x equal first, x value negative 3 equal 3t. From this we can have t equal negative 1. Then y values 4 equal 2t. From this we can have t equal 2. Therefore, you see these two are not equal. Therefore, we cannot find the t such that v1 equal 3 v2. That means v1 vector is not parallel to v2 vector. Therefore, we can say L1 and L2 are not parallel, right? These lines are not parallel. We know now they are not parallel, but need to check whether they are intersect. If two lines intersect, there must be a common point. Let me make x, y, z equals of both lines. You know what we did in the previous problem, right? So let me make x, y, z equals of both lines. So first one is negative 3t plus 1 equal 4t plus 1. Next one, not 4t plus 1, 3s plus 1, x, right? X. Then second one, I can say 4t plus 1 equal 2s plus 4. The last one, 2t plus 4 equal negative s plus 1. Alright, so let me use first and the last one, okay? So from the first one, we can have, you see s equal negative t from the first one. From the last one, we can have 2t plus s equal negative 3. Then we plug the s equal negative t. So 2t plus negative t equal negative 3. Then t equal negative 3. Since t equal negative 3, from this we can say s equal 3. Right. Now we use the second equation to check whether this satisfied. So let me check. Yes, s equal 3, t equal negative 3. Therefore, 4 times negative 3 plus 1, we need to check whether this equal or not. 2s equals 3 plus 4. Solving this, you see negative 12 plus 1 negative 11 equal 6 and 10. Actually, you see these two are not equal. It means second equation is not satisfied, right? Therefore, we can say these two lines do not intersect, right? These two lines, because second equation is not satisfied with s and t values. Right? Therefore, we can say the lines do not intersect.